Alright, so we are going to get started on our new topic today, even though I'm not here. We're going to go ahead and just do this on a video lesson. So hopefully you're all able to access this. And we're going to start our new chapter, which is on systems of equations. So to introduce that concept of systems of equations, we need to start by reviewing what it means to be a solution to a single equation. An equation like y equals 2x plus 1, in order to find solutions to that, we started by plugging in numbers for x and getting outputs for y. We did our input outputs, our tables, and those types of things. And we came up with solutions such as this. If x is 0, y is 1, because 2 times 0, because I'm just substituting 0 in for my x here, 2 times 0 plus 1 is 1. So if x is 0, y is 1. X is 1, 2 times 1 is 2, plus 1 is 3. If x is 2, 2 times 2 is 4, plus 1 is 5. And so we just kind of follow that rule all the time, that we plug in an x, and to get our y, we take our x times 2 plus 1. So that's what we're talking about when we're doing our system of equations here, is we're going to talk about solutions. And to begin with here, like I said, we're going to review what it meant to be a solution to a single equation. Now, based on what we've done previously, you should be able to answer this question. What is the easiest way to represent all the solutions to that equation? Because obviously we've listed 3 there, and then we gave the formula, and we said there's a lot of different equations. Well, hopefully you're able to answer that question by saying the easiest way to represent those is to create a graph. So based on what we've done previously in this course, we should be pretty familiar with the y equals 2x plus 1, that we can graph that just like we took those points. We plugged in an x, got a y, and we have the point 0, 1. We have the point 1, 2, and the point 2, 5. We found all 3 of those points by plugging them in, but we also know our shortcut for graphing, where we start at our y-intercept of 1, and we go up 2 over 1 to get to our next point, because that number in front of the x is our slope. You will absolutely need to be able to graph to do this unit. So those of you that are struggling a little bit with graphing might have to ask someone around you for help. Just make sure you're getting your graphs correct, or else all your answers will be wrong today. So this is all the stuff we've talked about previously. We've talked about solutions to equations, and we've talked about how a graph represents all the solutions to an equation, because that pattern is going to continue on forever. That's why we put the arrows on the graph. So now we can get into our new material. Now that we remember what a solution is and the fact that we can graph the solutions to an equation, that leads us into our systems of equations. And what a system of equations refers to is 2 separate, and actually we can do systems with more than 2, but for this class we're going to stick with 2 separate equations with the same variables. For example, both equations will be written y equals, or x with x and y both in the equations. Now, a solution to a system of equations, when we talk about a solution, we just talked about how each equation has millions upon millions of solutions, because you could plug in any value for x and get a y out. So when we're talking about a solution to a system of equations, we're talking about the solution that is shared by both equations. So there's going to be one point, or one xy value, that works for both equations, and we'll show you more of what that means in a moment. Now, what that means on a graph, because remember, our graph is a picture representation of all the solutions to our equation. So on a graph, that means you could graph both equations and find the point where they meet, because each graph represents all the solutions to that equation. So the point where they intersect, or the point that's on both lines, would be the shared solution to both. So that would be our solution point. So that's how we're going to solve systems today. We're going to solve systems of equations by graphing. So let's look at our first example. This is a system of equations where we have both of these equations, y equals 2/3 x minus 2 and y equals negative 1/2 x plus 5, and we want to know what is the one point that would be a solution to both of those equations. So to do that, the easiest method right now would be to simply graph them and see if we can find the point where they intersect. So in order to graph y equals 2/3 x minus 2, I start at my y-intercept and I apply my slope, up 2 over 3, up 2 over 3, and I draw in my line. So there's my first equation, y equals 2/3 x minus 2. That's the set of all points that's a solution to y equals 2/3 x minus 2. I do the same thing now for my second equation, y equals -1/2 x plus 5. So I start at my y-intercept, and my slope of -1/2 tells me to go down 1, right 2. And now I'm going to continue that on until they intersect, because I want to know the point that is a solution to both. In other words, I'm looking for that point where they intersect. So I'm going to draw in my line now, and we see this point here, the point 6, 2, is the point where the two lines intersect. So that represents the solution to my system. So as far as solving systems of equations goes, all you really are doing here is just graphing, which we've done many, many times over before. We're just graphing two different equations and finding the point where they meet. Now, what that means algebraically is if x is 6, y is 2, that must be a solution. X is 6, y is 2, must be a solution to both of those equations. So if I plug 6 into my top equation, 2/3 of 6 minus 2, I do 6 divided by 3 is 2, times 2 is 4, 4 minus 2 is 2. So if x is 6, y is 2. And I can do that same thing for the second equation. -1/2 times 6 plus 5. -1/2 times 6 is -3. -3 plus 5 is 2. If x is 6, y is 2 is a solution to both equations. For example 2, I would like you to pause the video and go to a piece of graph paper and see if you can find the point where these two lines meet. So go ahead, pause the video, and after you've found the solution, go ahead and push play again and we'll check your answer. Hopefully you were able to find the solution to this without too much difficulty. If you did have some trouble, let's look at how we should do this. And we notice when I graph y equals 2x plus 4, I start at 4 and I go up 2 over 1, and now I'm off my graph. You're able to go probably one more point on your graph. And when I graph my second line, y equals 1/2 x minus 2, I start at -2 and I go up 1 over 2. And this is where some of you may have started to run into an issue, because you're noticing here my lines are getting further apart as they go out. Well, hopefully some of you were able to pick up on the pattern that their lines, they go on forever in both directions, not just to the right. So if I do my black line, y equals 2x minus 4, I can apply my slope backwards and say I'm going to continue to follow this pattern down 2 over 1 as I go back, and that line is going to continue on forever. Same thing with my blue line. My slope is 1/2. Normally I go up 1, right 2. I can continue that pattern by going down 1, left 2, and my lines actually intersect over in the negatives at the point -4, -4. So when you do your solutions to your systems, you may have to go into the negatives in order to find where the graphs meet. So this will be your homework today, is you're going to have to graph two equations and find the solution to that system. Find the point where they both meet.